Welcome to our live training session number 6, part 4. In this video, we're going to be taking a look at working with our closed loop boost control, setting up our vehicle speed and gear ratios, as well as taking a look at our idle control. We're going to have a lot to learn, so let's jump into this live training session so we can get started.
Welcome to our live training session number 4 with our R34 Skyline. So in the previous video, we were optimizing our spark timing and we were setting up our knock threshold table, as well as dialing in our manifold pressure compensation table here the best we could off of our wastegate spring. So we got all that set up, and now we're ready to start turning up the boost. So we want to go in and work with our boost control. So let's jump in here and take a look at a couple things to get started so we can learn how to work with the boost control and then learn how to go through the data logs and see what we're going to be looking at and know what to go in and change and how that process is going to work. So let's jump down in here to our boost control page. And let's actually jump into our boost control. So looking here, and our target boost. Now we set our target boost to 16 PSI. And actually I have my previous data log open right now. I'll go to playback, and looking through this, we see that our boost went to about 14.5, 14.7 PSI. That's okay, that's off the actuator, the wastegate actuator. So we set our target boost a little bit higher than that, and that's going to be a good starting point. We want to go usually about 2 pounds higher than whatever we baseline off of our wastegate spring or wastegate actuator. Next, we're going to move into our closed loop base duty table, and this is going to be where it sources the actual duty cycle from to start to control for the boost. So this is a feed-forward style system, and this table here is going to allow you to populate your boost control a little bit more accurately. If we didn't have this table here, it would have to go into our PI and D values, and it would start to just simply calculate from 100% duty cycle, and it would have to try to figure out where the duty cycle is going to be at. This feed-forward table here is going to say, hey, start at 30% because that got me pretty much on point to that target boost, and then control from there, and it's going to make things a lot easier. So what I'm going to do in this situation here, go to a target boost table. I set it at 16. We know that our lowest point of operation is going to be about 12 to 13. Again, looking here at our data log, kind of panning through, it starts off right about 11, 12, then it boost creeps a little bit as we get to the high RPM, about 14. So we know our wastegate actuators are about 11, 12 PSI actuators. That's approximate. And the boost creep's kind of normal here. It's not something to be super concerned about. Let's go to close playback. I'm going to be redefining my target boost levels in this table here. I'm going to go to my breakpoints, and I'm going to be starting my first one here, let's say at 12. Next one, I'll go here at 14. I'll put my next one here at 16, then 18, then 20, 22, 24. Let's even go up to 28. I don't know how much boost I'm going to run on this engine. This is on pump gas, so we're going to be limited somewhat, but this is a relatively low compression engine, so there is going to be a bit of a headroom that we have available to us. We also can go here and set our duty cycle versus RPM. This is going to allow us to have a little bit more control than just the target level alone. So oftentimes, as RPM goes up, we're going to have to start increasing the duty cycle, and that's going to just increase the further accuracy of this boost control. It's going to allow us to pretty much hit our target wherever we want. And then under PID here, as these values start to kind of kick in and start to adjust from that set point here that it's going to be saying, hey, run this particular duty cycle, we can fine-tune that even further, and the PID values can be pretty low and have minimal interference with the boost.